part of iDesign as well. We went to Candela, Panama, and we basically followed a natural spring source, and the community members were just really curious about what we were doing. So we just traipsing up and down these mountains all day. We're part of iDesign, and as you can see in the picture in the bottom left corner, we felt that to epitomize iDesign, we were covered in rain the whole week, so that really just informed the data collection we could contribute throughout the week. It's really not working like it's supposed to. This is Freddy's very nice way to present your sorry about that. All right, we are Team Candela, which is the community we went to in Panama. My name is Natalie Minot, and I'm an environmental engineering student.
I'm Steve Kowski, I'm a civil engineering student.
Other members of our team include Stephanie Tall, which is a civil engineering student, and also Jordan Houghton, a construction management student.
We're going to talk about our community, which is the Candela community. We're going to give you a brief overview of the water supply that they have there and what's available. We're also going to talk about data collection and our initial analysis and some preliminary design we have. The community we were in was also in the Marca Noble Bouvet. We were also with the Noble people. And we flew into Panama City over there, which is the capital, and it's about 3 million people. And then we traveled 5 hours west to a community of near 250 people. So it was a big cultural change, big change. And, we were about halfway between the Indians and the community, they're very nice, very friendly. Marco was kind of the community leader, and he had some of the kids develop maps of all the houses so we could figure out where everyone is and how their water system works. A typical house, you can see in the upper picture there is a tin roof with bamboo siding. This is just some typical clothing that the community members wear.
Okay, so now we're going to delve into what our purpose was there. As engineering students, we were trying to figure out how to get water from a natural spring source to all of the homes in the community. System 1 was built by the World Bank 12 years ago, and it consisted of a spring box which encloses a natural spring source from contamination. But as you can see here, the front of the spring box is quite dilapidated, and small animals and other contaminants from natural organic matter can get into this spring source. So it's really not enclosed like it should be. From this natural spring source, it feeds down by gravity into a water storage tank, which is about 6,000 gallons. And from the get-go, this was supposed to serve the entire community, and it didn't because there were a few elevation changes that were too drastic to reach all the homes. In this water storage tank, it also doesn't have protection on the inlet pipes, so we were looking at crabs in the storage tank, which is not ideal. Lastly, there's the clean-out valve in the storage tank, and a family nearby uses it to do their laundry. So this empties the entire tank while they're doing that, and homes past it can't get water. So it's just educating these community members with conservation. System 2 evolved because the System 1 could not serve all the houses in the community. This is Marco, who Steve mentioned earlier, and he took us around to all the water systems. This is his own spring box he built. It's not enclosed, as you can see, but it serves all the homes year-round, so he did quite a good job. System 3 was built because there were about 5 homes in the community that could not get water at all because they were way too high in elevation. So they just basically collect water from a surface water source, and it doesn't work year-round because it's runoff from the rainy season. While we were living in Candela, we did numerous types of data collection. First, we did water quality testing because we saw all these open sources for their water collection. We figured they would be contaminated. What we found was good because they didn't have sources of fecal matter with their water. We just found coliform, which in the United States we would say, you can't go swimming in this water even, but at the Candela community, they're safe. It's not in contact with fecal matter. The most important data collection we did was the survey analysis we did with the Abbey level survey. And there were drastic elevation changes. We wanted to collect the topographical image of this Candela community. We were in quite treacherous terrain, as you heard from the team before as well. So we also, we were able to use community members. They were out there willing to help us with this data collection, taking the pipe length and everything like that. Lastly, we did flow calculations as well as GPS point collection. And while we were working with these community members, they taught us about when people got sick and how much water they used throughout the year.
The next phase, when we got back here, got back to America and we're eating pizza and hamburgers again, we started taking all the data that we compiled, some of the community interviews and admin level surveying and all that data, and we started to figure out, okay, what do we have here, and what do we need to design? How best can we serve the community, and how can we meet the needs that they mentioned? So one of the first things we looked at was the demand, because the biggest issue was in the dry season, a lot of these homes weren't able to have water, and they would have to go to the nearby river, which obviously isn't a safe source. And from that, we kind of determined that we may need to look for system one. We may need to look for another spring. We found another one there, and maybe tap into that to meet our dry demand. We also took some GPS data, and this allowed us to make a Google Earth map out where all the houses are, where the evals are, and kind of where some of the deficiencies in the system are. Another thing we did is from our Abbey level surveying data, we were able to kind of plot this map. On the upper left here, that's where the spring box is, and all the houses on system 1 are here with the Abbey level surveying. And then system 3 is over on the far end. As you can see, there's a pretty big hill that the pipe needs to traverse in order to get there. And so we're looking at either putting in a pump system or maybe increasing the diameter of the pipe to decrease the amount of pipe on. And so that gets us to our preliminary design. We've looked at some possibilities for putting in a spring box. And the idea with our design is to give the Peace Corps some good recommendations. So when they get a full-time Peace Corps volunteer in the community, he can see kind of what we've done and just gives him or her an idea of how that they can best serve the community. We also found that they can get chlorine tablets, and so we were looking at putting an inline chlorinator in the tanks. And we also come up with some basic ideas for a pumping system.
We wanted to thank everyone who made our time in Panama possible while we were actually there. First of all, the Peace Corps volunteers. Steve mentioned we didn't have one living at our site, which was not common with any other group there. So that was an obstacle we faced, and Lindsay was our main Peace Corps volunteer. She worked with the community in building latrines for them before, so they were comfortable with her and okay with letting all these Gringos into their community. So we also had Lauren and Aaron, who took some more data collection with us, as well as flow measurements in the dry season when we're not there. And the Candela community members. Everyone was out every day to help us with the surveying, to cut through the forest and show us where the pipe was buried. Mostly we had Marco, who showed us all of the water systems, and he was communicating with family members. Lastly, our team mentor. Ashley Mays was an international senior design student 2 years ago. She's now into grad school, but she came back for 2 weeks to help us figure out what data collection we needed, and she was really vital in knowing what we needed to do.
All right, now if you liked our presentation and what we had to say, you can join us in the afternoon, the second afternoon session in Dillon Hall, room 320. And we have developed a water system, and we're going to split it into groups, and you guys are going to help manage this system. And the goal is to kind of a competitive game to see who can collect the most water from our system. So thanks for your time.